Hello and welcome to my YouTube channel. My name is Neha Kukreti and from today's onwards we are going to discuss Lagrangian dynamics. We use Newton's laws to discuss the motion of particles, but in this approach we need to know all the forces acting on the body at all instant of time. But in actual situations where constant forces are present, Newtonian approach becomes a difficult task. In this approach, we try to solve the problem geometrically rather than analytically. So, determination of constant forces becomes difficult task. In order to overcome this difficulty, certain methods have been developed by D'Alembert, Lagrangian, Hamilton, and others. In this series of lectures, we will understand and use Lagrangian formulation. So, let us first discuss about the basic concept of motion of particles. Okay, motion of particles. So, to understand the motion of particles, what is important? It is important to know its position. Okay, to know its position and how the position is changing with time. For that purpose, we need to learn about the coordinate system. And there are three widely used coordinate systems. They are number one, Cartesian, Cartesian coordinate system. Number two, spherical coordinate system. And number three, cylindrical coordinate system. In Cartesian coordinate system, the position vector r, okay, it is represented by x, y, and z. While in spherical and cylindrical, represented by r, theta, phi, and r, phi, z. So let us discuss these coordinate systems one by one. We'll start with Cartesian and then we'll discuss spherical and cylindrical. Cartesian coordinate system. Here we use x, y, and z coordinates to represent a vector. Let us consider vector A. So how we are going to represent this vector in the Cartesian coordinate system? We'll write it as ax x cap plus ay y cap plus az z cap, where x cap, y cap, z cap are unit vectors along x, y, and z axis. And how we are going to draw this? Z axis, y axis, x axis. This is a point, this is a vector A. So we'll move ax along x direction, then ay along y direction, and then az along z direction, and finally we'll reach this point. Okay, so any vector A in Cartesian coordinate system is represented by this, where x cap, y cap, z cap are the unit vectors along their respective axis. Okay. Now, if we want to write the position vector. Now, what is a position vector? A position vector is a distance of this vector from the origin. This is the origin, and the distance from the origin is called the position vector and is represented by r cap. Okay. Let us redraw this and explain and understand what is position vector. Let us consider point P. Then how we are going to write a position vector? Position vector is the distance from the origin. Okay, r. and its unit vector is along r cap direction. So in Cartesian coordinate system, it is written as x cap plus y cap plus z cap, where its magnitude is given by x square plus y square plus z square root over. Okay, its magnitude is given by x square, y square, z square, and the unit vector r cap is given by vector r upon the magnitude of r. Okay, so it becomes x cap plus y cap plus z cap upon square root of x square plus y square plus z square. So this is all you need to know in Cartesian coordinate system. Okay. Now let us discuss spherical coordinate system, where a vector A is represented by ar cap plus a theta cap plus a phi cap. Now let us draw point P. This is point P, and this point P always lies on the surface of the sphere. Okay, lies on the surface of the sphere. Now this P is represented by r, theta, and phi, y, and x. Now first let us understand what is this r, theta, and phi. Okay, so r, we already know it is the distance of this point P from the origin. R vector. This is the unit vector r cap. Now theta is this angle. It's moving clockwise. Okay, so this is theta. Now theta is the angle made by this position vector from z cap axis. Okay, see, after that we need to know what is phi. So for that we have to take its reflection along x and y plane, and let us join it from the origin. Also we can resolve this r component, we can resolve this r vector into its component form. So how can we do that? This is r, so here we'll get r cos theta, and along this we'll get r sin theta. So this reflection point is nothing but r sin theta. So as you can see, this becomes a plane. Now this plane makes an angle phi with the x-axis. This angle is called as phi. Okay. So now let us resolve this r sine into along the x and y axis. So how are we going to do that? Phi and r sine. So along this we'll get r sine theta cos phi. R sine theta cos phi. And Along y-axis we get r sine theta sine phi. Now, how are we going to write x, y and z axis? What are the x, y and z points? Now, so x equals to r sine theta cos phi, y equals to r sine theta sine phi, and z equals to r cos theta. Also, if x, y, z points are given, then we can write it in terms of r theta and phi. So r equals to x square plus y square plus z square root over. Theta is equals to cos inverse z upon r. And with the help of these two, we can find phi equals to tan inverse y upon x. So if x, y, z points are given, we can find r, theta and phi. And if r, theta and phi values are given, we can find x, y and z points. And yes, also this r is the, you can say, since p is the point that lies on the sphere. Okay, so this r that we are, this r vector is nothing but the radius of the sphere. Okay. Now we will discuss about the last coordinate system, that is cylindrical coordinate system. Here any vector A can be written as AR r cap plus A phi phi cap plus AZ z cap. Now let us draw our axis z, x and y. This is the point P which is presented by r, phi and z. Now here r is the, since P is the point on the surface of the cylinder. What is P? It is a point on the surface of the cylinder. So this r is the radius of cylinder. Now we will not draw this r from the origin, but it will be a distance from z-axis. Okay, distance of point P from the z-axis. In cylindrical coordinate system, this r is the distance of point P from the z-axis, which is different from the spherical coordinate system, where point P, the distance of point P from the origin was r. Okay, that is the radius of the sphere. Here it is radius of cylinder and it is the distance from the z-axis. Now let us draw its reflection. Okay, this. So the plane that is containing the r makes an angle from the x-axis, and that angle is called as phi. Okay, and z is the distance along the z-axis. So this is our cylindrical coordinate system. Now, what are the unit vectors here? This is the r. So in this direction we get r cap. Since phi is moving along this direction, so this gives us phi cap and this gives us z cap. Now, let us see how we can write in terms of r, in terms of x, y and z. So x equals to, again resolve this along x-axis, what we get? R cos phi. Okay, and along y-axis we'll get r sin phi. So it becomes simpler in cylindrical coordinate system. So x equals to r cos phi y equals to r sine phi, and z is z only. Okay. So now how we can write r, phi and z in terms of x and y. So z remains same. R is equals to x square plus y square root over. Okay. And phi equals tan inverse y upon x. So if x, y are given, x, y and z are given, you can find the points r, phi and z. And if r, phi and z are given, you can find it in terms of x, y and z. So this is all about the coordinate system that you need to know, and it is an important part because in further when we will learn about the Lagrangian, how we write Lagrangian, there we want to write the kinetic energy and potential energy in terms of different coordinate system. Depending upon the problem that we will get, will decide which coordinate system will give the best results. For that purpose, you need to know about these systems, and later on we'll know how we can write the kinetic energy and potential energies in all these coordinate systems. So thank you so much, and keep learning.